Hi friends, good evening. Welcome back to my channel Belagali's class. My friends, already we have started with Vectors, done almost the basic concepts of what? Vectors. Yes, my friends. Now, just I want to remind these things, basic concepts. One is a triangular law of addition. If AB equal to A and BC equal to B are the given vectors, then factor AC, tell my friends what is this? It is a factor joining the initial point of the first factor to end point of the second factor. This is resultant, you can say. That will be sum of what? Factors AB plus BC. The same thing is written. Therefore, vector AB plus factor BC is AC. This addition of two factors exists only when end point of the first factor is same as initial point of the second factor. End point of the first factor, my friend, the first factor is same as initial point of the second factor. Then only that addition exists, otherwise no. Down is a parallelogram law, my friends. This is a parallelogram law. It is a parallelogram law. Yes, my friends. 10. If OA and OB are the factors, adjacent sides of what? Parallelogram OACB, then the diagonal OC represents, what is this OC? It is a diagonal starting with co-initial point of the factors OA and OB. Yes, my friend. OA, OB, OC, they are the co-initial vectors. Then this factor OC represents the sum of the factors OA and OB. Therefore, OC equal to OA plus OB, diagonal starting with the same point. So it is A plus B. Here I have written one more result, my friends. What is this? Magnitude of the factor OA. Magnitude of the factor OA is nothing but length of the factor OA. This line length OA. Yes. Next. If OA equal to A is the unit factor, then the magnitude of OA equal to the small OA, its length is 1. Or magnitude of A is also what? 1. Second, if O is the origin of reference and P is any point in the plane or space anywhere, then OP represents, or OP is called as the position factor of the point P. I have written in brief. Position factor of the point P. Then we have done one result. It is also already done, my friends. What is that result? Any factor AB can be expressed in terms of position factors. What is any factor AB equal to? Position factor of the second point minus position factor of the first point, where O is the origin of reference. My friends, these are some basic concepts just reminded before going to one great result, my friends, wonderful result. Yes. Now we shall look at the result. Yes. This is the result. Position factor of the point P, what is its symbol? Factor OP. In the XY plane means, my friends, coordinate geometry. It is x-axis. What is it, my friend? This is y-axis. Their point of intersection is origin O. Yes, my friends. In the XY plane is defined as, this is very important, defined as the ordered pair XY of real numbers. Yes, everything you have studied in case of what? Coordinate geometry. Therefore, if PXY is any point in the plane, then OP equal to XY is the position vector of the point P. Position vector of the point P. That is OP equal to XY. OP equal to XY. Yes, my friends, some deduction is there. Let PXY be any point in the XY plane, then OP equal to XY. OP equal to XY is the position vector of the point P. OP equal to XY is the position vector of the point P. Draw PM perpendicular to OX. PM perpendicular to OX. PN perpendicular to OY. Then by the figure, my friends, what is OM? OM is a distance along x-axis. This OM gives the x-coordinate of the point P. X-coordinate of the point P. What is the x-coordinate of the point P? Is x. This is x. Then, my friends, we know this result. What is that result? Magnitude of OA, vector OA is nothing but that line segment OA. Line segment OA. Yes, my friend, here. This gives magnitude of the vector OM. I have converted this distance into vector. When it is a magnitude, it is the distance OM itself. But what is the value of OM is x. From this it gives, my friend, magnitude of the vector OM is x. Similarly, ON, this is ON. What is ON? Along y-axis. Along y-axis is y-coordinate of the point P, which is y. Magnitude of ON is ON equal to y. Therefore, magnitude of ON is y. OM is x, ON is y. Now we know that unit vector in the direction of the vector A is a definition, my friends. Unit vector in the direction of the vector A. I take this is the vector A, my friend. This is vector A. Then unit vector means its magnitude is 1. Then this A cap. What is this A cap? A cap is a unit vector. Its magnitude is 1. What is its direction? It is in the direction of what vector A? Unit vector in the direction of vector A is same as, along the vector A is same as, even in the direction means when you can take parallel line is also what? In the direction of the vector A. Therefore, I have written the same. We know that unit vector in the direction of vector A. Direction of vector A means along the vector A. Direction of vector A means along the vector A. This is along the vector A is denoted as A cap and is defined as A cap equal to vector A divided by its magnitude. Definition: A cap equal to vector A divided by its magnitude. What is this, man? It is a unit vector in the direction of vector A. That unit vector equal to the same vector A upon its magnitude. From this you can bring this side, my friends. So magnitude of the vector A into unit vector. Magnitude of the vector A into unit vector is vector A, or this is same as what? Vector A equal to its magnitude into, what is it? It is a unit vector in the direction of what? Vector A. Vector A can be expressed as what? Its magnitude into, what is this? Unit vector in the direction of vector A. A cap. This A cap. Yes, my friend, you name this as 1. Next. Let I and j are the unit vectors along OX and OY, means in the direction of OX and OY. Then using this result, 1. Using this result, we can write vector OM. This we have converted, my friends. Vector OM equal to its magnitude. Magnitude of OM into, what is it? Unit vector in the direction of OM. What is this? Unit vector in the direction of OM. What is that unit vector? Is I. Therefore, vector OM equal to magnitude of OM into I have written there. But what is magnitude of OM is x. Therefore, this is x into I. From this it is clear. Factor OM equal to x into I. I have written factor OM is x into I. X into I, my friend, yes. X into I. Similarly, factor ON, this my friend, this is factor ON. This. What is this? It is a unit factor in the direction of factor ON is J. Therefore, factor ON equal to magnitude of ON into unit factor along ON is J. I have written ON equal to magnitude of ON into J. But what is magnitude of ON is Y. This is Y. So Y into J. Y into J. Therefore, my friend, factor ON equal to what is this, my friend? Y into J. Y into J. Yes, my friend. Now I use what? Parallelogram law. Yes. Which diagonal? OC. OA plus OB. See, my friend, here. See. Now, by parallelogram law, which parallelogram? OMPN. OMPN, it is a parallelogram. OM and ON are the adjacent sides of the parallelogram. OP is the diagonal starting with the same co-initial point O. Therefore, from the parallelogram law of addition, factor OP equal to OM plus ON. Parallelogram law. Factor OP equal to factor OM plus factor ON. But what is OM? OM is XI, my friend. What is ON? This is YZ. Therefore, OP equal to XI plus YZ. XI plus YZ. Then what is the magnitude of OP? Is a line OP. What is this OP, my friend? If you take only line OP, the distance between the origin, what are coordinates? 0, 0. And point P, what are coordinates? X1. Therefore, OP is the distance between the points O, origin 0, 0, P, x1. Use the distance formula. Difference of x coordinates, x2 minus x1 whole square plus y2 minus y1 whole square. Simplifying, you get what? Root x square plus y square. Yes, my friends. From all these, this is the important step, my friends. This theorem so far not appeared any board exam, nothing else. But for the knowledge, what is it? If Pxy is any point in the xy plane, then OP is the position vector of the point P, and that position vector of the point P equal to, yes, x coordinate multiplied by I plus y coordinate multiplied by j. What about I and j? They are the unit factors along OX and OY. Therefore, OP is this. Then what is its magnitude? Magnitude of OP is root x square plus y square. Yes, my friends. Remember, if P is any point in the xy plane, then OP is the position vector of the point P and is given as vector OP equal to xi plus yz, and magnitude of OP is square root of x square plus y square. What they are? They are the square root of what? Square of x coordinate plus square of y coordinates. That is magnitude. Similarly, my friends, now we will jump to this xy plane to space now. This is the space. It contains what? 3-dimensional. It is 2-dimensional, it is 3-dimensional. It is x-axis, y-axis, z-axis. Yes, my friend. Let P, x, y, z be a point in the space now. This is the plane. This is the plane. This is the space. This is the space P. Then what is OP, my friend? Position vector of the point P with respect to O. Then vector OP equal to x coordinate multiplied by I. Or what about this? IJK. IJK are the unit factors along OX, along OY, along OZ. Then vector OP is x multiplied by I, unit factor, plus y multiplied by j. Yj is along OY, plus z multiplied by k. Then what is the magnitude of OP? Root x square plus y square plus z square. The same is written, my friends, here. Similarly, if p x y z is a point in the space and I comma j comma k are the unit vectors along ox, oy, oz axis, then factor OP can be given as xi plus yj plus zk, and magnitude of OP is root x square plus y square plus z square. Now, connected with this, my friends, connected with this, if you take simply x, y, z, what they are the coefficients of ij, coefficients of I comma j comma k. They are known as scalar components of the factor OP. If you take along with ijk, xi, comma yj, comma zk, they are called as factor components of the factor OP. Therefore, x, y, z, they are scalar components. Xi, comma yj, comma zk, they are factor components of the factor OP. Yes, my friends. From this, it is important is what? This star, very important is this double star. Yes, my friends, these are the factors. And one more thing is what? What is I comma j comma k here? I comma j comma k are unit factors. Then what about their magnitude? Unit factor means their magnitude is 1. Therefore, magnitude of I is 1, j is 1, and magnitude of k is 1. Therefore, I, j, k are unit factors. Their magnitudes is 1. Yes, my friends, I give 2 minutes. Please copy these things. Friends, these steps are important. They are important. Normally, the proof up to this not appeared in any exams, my friends. But this is very, very useful result. Very basic, useful result. Yes, my friends. My friends, I hope it is clear. Remember only this. If Pxy is a point, I take this. Normally we go for the space. If Pxyz is a point in the space, I comma j comma k are the unit vectors along Ox, Oy, Oz. See the figure. Then position vector of the point P is factor OP. How to write it? X coordinate multiplied by I plus Y coordinate multiplied by J plus Z coordinate multiplied by K. This is the position vector of the point P. Then what is its magnitude? Same. Root of square of X coordinate plus square of Y coordinates plus square of Z coordinates. In this, my friends, simply if you take X, Y, Z, they are the scalar components. If you take along with the factors Xi, Yj, Zk, they are vector components. Vector components. If you wanted to write another note there, that note is about Ijk. Yes, friends. Since note since I comma j comma k are unit factors along Ox, Oy, Oz unit factors, therefore magnitude of I is 1, magnitude of j is 1, and magnitude of k is 1, my friends. Their magnitude is 1 because they are unit factors. Unit factors means what? Magnitude is 1. Yes, friends. Now I do examples connected with first 1 mark questions. My friends, examples is 1 mark. First example. Find the magnitude of the following factors. Find the magnitude of the following factors. Also, following factors. Yes, first one. First is factor A equal to 2i minus 7j plus 3k. Yes, my friend, see here. If the factor OP is xi plus yj plus zk, then what is its magnitude? Square of coefficient of I square, coefficient of j square, coefficient of k square. This, my friends. So, magnitude of the factor A is square root of 2 the whole square plus coefficient minus 7 the whole square plus coefficient 3 the whole square, which equal to square root 4 plus 49 plus 9. Tell my friend, what is this? 9, 18 plus 2, 22. 2 plus 4 is 6. It is square root 62 units, my friends. Square root 62 units. Next example. Next example. Yes. Second, factor B equal to, this is 1 by root 3 into I plus 1 by root 3 into J plus 1 by root 3 into K. So, magnitude of factor B, yes, It is a square root of squares of scalar components 1 by root 3 the whole square plus 1 by root 3 the whole square plus 1 by root 3 the whole square equal it is square root of 1 by 3 plus 1 by 3 plus 1 by 3. My friend, LCM is 3, numerator 1 plus 1 plus 1, 3 upon 3, square root of 1. What is square root of 1 is 1. And the magnitude of B is 1, it is nothing but what? It is a unit factor. This is a unit factor. Next, my friends, one more. Yes. This is third example. Vector C equal to root 3 by 2 into I plus 1 by 2 root 2 into J minus 1 by 2 root 3 into K. You have to find once again its magnitude. Same, my friend. Magnitude of C, vector C. It is square root of root 3 by 2 the whole square plus second 1 by 2 root 2 the whole square plus third one minus 1 by 2 root 3 the whole square. Yes, friend, it is square root of root 3 the whole square is 3, 2 the whole square is 4 plus 1 the square. It is 4 into 2 is 8 plus 1 by minus the whole square is plus 4 into 3 is 12. Tell my friends, what is the LCM? It is square root of LCM is 24. 4, it comes, my friend, 6. 3 into 6 is 18. Plus it comes 3. 3 into 1 is 3. Plus it comes 2. 2 into 1 is 2. My friends, this is square root of 23 upon 24 units. Square root of 23. 18 plus 2, 20 plus 3 is 23 upon 24. This is the magnitude of this factor. Yes, my friends. These are how to find the magnitude of the given vectors. These examples are important under 1 mark, 2 mark questions. 1 mark, otherwise 2 mark questions. 2 mark questions. It depends upon the examiner. Next, my friends. Next is slight different. Yes, friend. Yes, that question is yes. Find the value of m. This is fourth example. Find the value of m. Value of m if the vector a equal to 2 by 3 into I plus 1 by 3 into j plus mk is a unit factor. Yes, my friends. You wanted what? Find the value of m unknown. M is here. What is given? A is a unit factor. A is a unit factor. Yes, my friend. Given is a unit factor. Unit factor. Unit factor means, my friend, its magnitude is 1. See here. If OA equal to A is unit factor, then its magnitude is 1. What is the magnitude of the factor A? Square root. Square root. Square 2 by 3 the whole square plus 1 by 3 the whole square plus third one K coefficient m square equal to 1. Square both sides. Square. Square root cancels. 2 by 3 the whole square means 4 by 9. 9 plus 1 by 9 plus m square is 1. 9 is the LCM. 4 plus 1 is 5 plus m square is 1. Therefore, what is the value of m square? M square is 1 minus 5 by 9. Simplification. 4 by 9. What is m? Square root of this plus minus 2 by 3. This is the value of m, my friends. These are very simple examples. This is also good example. Good example. Next, one more of the same type. Same type. Yes, friends. Find the value of lambda. Next example is fifth one. Find the value of lambda if factor A equal to, if factor A equal to, this is 2 lambda I plus minus 3 lambda j plus lambda k is a unit factor, is a unit factor. Same as previous example. Yes. Given A is unit factor. Unit factor. Therefore, its magnitude is 1. Its magnitude is 1. What is the magnitude? Square root of scalar components. 2 lambda whole square. Scalar components. 2 lambda whole square minus 3 lambda whole square plus lambda whole square is 1. Square both sides. Square. It is what? 4 lambda square plus 9 lambda square plus lambda square is 1. If you add, then it is 14 lambda square is 1. Then what is the value of lambda square? It is 1 upon 14. Therefore, the value of lambda square root 1 is 1, root 14. Root 14. Yes, my friends. Now this is the second example. Same type. Same type. Next, my friends, I do one example connected with how to find the scalar components as well as vector components. Scalar components as well as vector components of the given vector. Then we have to express the given vector in the form of what? OP. OP, position vector, OP. Then, my friends, coefficients of ijk are scalar quantities, components, including ijk, they are vector components. Yes, my friends. One example based on that. Yes, friends. The example is find the scalar and vector components. This is example number 6. Find the scalar and the vector components. Vector components. Components of the vector whose initial point is my friends, it is 2, 1, and terminal point is friends, it is -5, 7. You wanted scalar and vector components of the vector. Directly vector is not given. Its initial point is given, my friends. This is the initial point of the vector A. What is it? This is given as 2, 1. Then its end point is given this. It is a vector from A to B. This is B, my friends. This is given. It is -5, 7. Then AB is your vector. AB is your vector. Yes, my friend, you know. If P, X, Y, Z is a point in the space, then what is the position vector of the point? OP, Xi plus Yj plus Zk. This is in the space. If it is in the two-dimensional, you have only two coordinates, X and Y. Then what is OP? Xi plus Yz here. If O is the origin of reference, if O is the origin of reference, then tell my friend, position vector of the point A, that is vector OA, position vector of the point A, OA, equal to x coordinate multiplied by I plus y coordinate multiplied by j. Tell. Then what is the vector OB? Vector OB multiplied by I plus 7j. Yes, my friends. So, initial n, if O is the origin of reference, then the position vector of the points A and B. OA and OB are written. After writing OA, OB, then you have to make use this result. Any factor AB can be expressed in terms of what? Position vectors. Position vector of the second point minus position vector of the first point. Use this result. Now, any factor AB, this my friend, factor AB equal to position vector of the point B, second point, minus position vector of the point A, first point. Now what is the value of OB? It is -5i plus 7j minus OA 2i plus j, simplify it. -5i plus 7j minus 2i plus with minus is minus j. What is this? -5 minus 2 minus 7i plus 7 minus j plus 6j. Tell my friends, what are the scalar components, coefficients of I, j? -7, 6 are scalar components. -7i, 6j are vector components of the vector A. Therefore, scalar components components of factor AB are coefficients, my friends, minus 7, 6 plus 6, and the factor components of the factor AB are, my friend, it is 7i, 6j. This is the question. It is also a good question under 2-mark questions, my friends. 2-mark questions. Yes, my friend. The next question is one more I do. Yes, one more. Right, my friends. So this question is, find the scalar and factor components. Find the scalar and factor components of the factor joining the points first P, its coordinates are x1, y1, z1, and second point is Q. It is x2, y2, z. Yes, my friends. These are the points and this is the factor. This is P, initial point, x1, y1, z1. This is the factor PQ. This point is Q. Yes. Coordinates. Yes. You have to write. If O is the origin of a reference, I write anyway. I have done what in detail. Position vector of the point P, OP, is x1i plus y1j plus z1k. I have written direct. All the cinema is there. I have written. O is the origin of reference, then position vector of the point A, OA, OB, like that. Now, anyway, you know it. Direct. Next, OQ. OQ is what? x2i plus y2j plus z2k. Then you have to make use. You wanted factor PQ. Yes. It is factor OQ, second point, minus factor OP. That result. Then what is OQ? This. OQ minus OP means x2 minus x1 into I. x2 minus x1 into I plus second y2 minus y1 into j plus z2 minus z1 into k. Then what are the scalar components? Scalar components of PQ. What they are? First is x2 minus x1, second, and this is third, my friend. And factor components of factor OP, you have to just multiply x2 minus x1 into I, y2 minus y1, y1 into j, and z2 minus z1 into k. These are, my friends, factor components. Yes, I do. One more example. Yes, my friends. I hope now it is clear. It is clear. It is clear. Yes, friends. Yes. This is write two different factors having same magnitude. Same magnitude. Magnitude must be same. But factors must be different. Yes, my friend. Yes. Factors A equal to it is I plus j plus k. And factor B equal to I minus j minus k are two different factors. Two different factors with same magnitude. What is the magnitude of A, my friend? It is square root of coefficients, scalar components. Yes, root 3. And what is the magnitude of B? Square root of, I write, this step is important. Minus 1 the whole square plus minus 1 the whole square plus minus 1 the whole square. This equal to same. Again it is what? Square means minus whole square is root 3. Therefore, my friend, magnitude of A equal to magnitude of B equal to root 3. Then these are the two factors, different factors having the same magnitude. Like this. Another example is same direction, my friends. Same direction. Yes. This is write two different factors having same direction. Yes, my friend. In this case, if you take factor A is I plus j plus k. Yes, this is factor A. Yes, my friend. What is this? This is factor 2A. Then K, man, what is Ka? Is a factor whose magnitude is 2 times the magnitude of the factor A, and its direction is same as what factor A? Magnitude is 2 times, and what is this? Directions are same. Therefore, 2A equal to 2I plus 2J plus 2K. They have the same direction. A and 2A have the same direction, but different magnitude. They have the same direction. Yes, my friends. One more. First, I give one simple definition, then one example, my friends. Yes. This is same magnitude. This is same direction. Yes, right. First, I give that definition. Yes. Node. Node. If the two factors are equal, node. If the two factors are equal, if the two factors are equal, then their respective scalar components are equal. Scalar components are equal. Yes, my friends, read it. Two vectors, if the two vectors are equal, then their corresponding scalar components are equal. Yes, my friends, if you wanted one example based on this example. If vector A equal to xi plus yz plus k, and vector b equal to 3i minus 4j plus zk, then or you can take one more, and vector A equal to vector B. Find x comma y comma z. X comma y comma z. Yes, my friend. Vector A equal to vector B gives corresponding scalar components. Of vectors A and B, corresponding scalar components of the vectors A and B are equal. Therefore, yes, my friends, x is 3, y is minus 4, and z is 1 coefficient of k. Yes, my friends. Yes. Now this is another example. Sometimes all these types of examples, varieties of the examples, the friend examiner, if they wanted to ask for very simple examples about scalar components, if the vectors are equal, their corresponding scalar components are equal, my friends. So this is one part I have done today. Very important thing I have done is position vector OP is expressed in terms of unit vectors I, J, K. If P is a point with coordinates x, y, z, I, J, K are the unit vectors along OX, OY, OZ, then the position vector of the point P equal to xi plus yj plus zk. Those coordinates of the points are multiplied by unit vectors xi plus yj plus zk. And the magnitude of OP is root x square plus y square plus z square. These are, my friends, some examples based on that. Yes, my friends. Today this much is enough. Hope you are happy. Be happy, my friends. Enjoy it. Thank you very much. Good day. Namaste, namaskara, namaste, my friends. Namaste.